of the container. A loose cover should be placed over the top to prevent the solution from splashing out. It's very important that this cover be loose, otherwise, if you don't completely dissolve the agarose, your finished gel will have regions of different concentrations, and your nucleic acid samples will not separate correctly. Once the agarose is fully dissolved, let it cool to 60 degrees Celsius. This prevents heat damage to the gel tray while keeping the agarose liquid. Once the agarose is cooled, you'll need to add a dye to the molten gel for later visualization of the size-separated nucleic acid fragments. You can use cyber green, but the best and most commonly used dye is ethidium bromide. When using ethidium bromide, you should always wear gloves, since it's a mutagen and a possible carcinogen that can be both absorbed through the skin and breathed in. Immediately after handling ethidium bromide, change your gloves to avoid contaminating other instruments or parts of the lab. Gel trays have 2 open ends that need to be sealed while the gel is solidifying. Using a disposable pipette tip, move any air bubbles to the edge of the gel. It's especially important to remove bubbles from around the comb, since these can affect the shape of the wells. It takes about 20 minutes to move the comb. Slowly and carefully pull the comb upwards vertically. You'll feel some resistance as the comb comes out of the gel. Then remember that nucleic acids are negatively charged, so they'll run through the gel towards the positive electrode. The connector to the positive electrode is coloured red, and the connector to the negative electrode is until the liquid is about 2 millimeters above the surface of the wells in the gel. This will make the gel easier to load and ensure the appropriate current runs through the gel. You should be able to see bubbles rising from the negative electrode. Once the fragments have separated sufficiently, it's time to visualize violet light. Cyber green is safer but less sensitive than ethidium bromide, which is a strong mutagen. In order to have a permanent record of the fragment separation on the gel, you need to take a photograph. This is done by placing the gel on a UV illuminator inside a box which also contains a camera. The illuminator is switched on and the gel image is displayed on a computer screen. The image can then be saved as a digital file or printed out. When heating an agarose solution, it's important that a loose top is placed on the container. If the top is too tight, there can be dangerous pressure build-up within the container, which can cause the container to break. When making an agarose gel, don't leave the gel solution unattended while it's heating in the microwave oven. A solution that's heated for too long will lose water, increasing the agarose concentration of the final gel, or even burning the gel mixture. Don't remove the comb from a gel before the gel is fully set. That will cause the walls between the wells to be destroyed and the gel will be unusable. Take care not to damage the wells when loading your samples. A damaged well can allow the sample to leak out and may cause contamination of other wells. It can also cause nucleic acid fragments to migrate unevenly. Make sure you don't load air into the wells along with your samples. Air can cause samples to be lost from the well into the buffer solution and can also cause contamination of neighbouring wells. Another mistake that can be made when loading a gel is to load the sample too quickly. This will also cause the sample to flow out of the well. Once you've loaded your samples, take care not to move the gel. Even a small movement can cause sample loss and contamination.